see two types of tanks underground and above ground. So we have these types of loading that includes dead, live, wind, earthquake, water load, soil load. So after that, we understand there are two important load cases, that is tank full and no soil backfill, and other is a tank empty with soil backfill. Okay, so for basically we have to consider these two main load cases in terms of some another load combinations. So after that we learn how to initial calculation of the member sizes, section sizes based on the thumb rule. Okay, and after that we started one design example of underground water tank of some assumed dimensions, like inside length of the tank is 12 meter, inside width of the tank is 8 meter. Suppose height of the tank is 5 meter, maximum water will be 4.5 meter. So we also after that calculate some loadings. So based on thumb rule, our wall thickness of the wall is somewhere around 500 thick. Base slab is 600 if there is a top slab, so that can be assumed as a 500 thick. Okay, so first our check will be for assumed wall thicknesses. If the tank is applicable or subjected to the water pressure, underground water pressure, then we have to find out the uplift check. If it is fine, and then we our assumed member sizes or thickness, those are totally safe. So then we can start some more digging into in terms of the analysis. Okay, so after that we also learn how to calculate the different pressures, how to calculate the water pressure on the tank, how to calculate soil pressure by considering Ka or Ko. Okay, for a tank empty condition, how to consider or how to calculate the additional surcharge. Okay, so till up to this, also we consider some factor load combination, deflection criteria. So up till this, now we have uh, completed some initial things. Now we, so there after this, yes, we obviously we have two options. We can go with some software like STAD Pro or any other like SAP or ETABS or anything. And but like I am previously mentioned, so before that we need to some have understanding of that tank, its behavior, how it will be. Suppose if we consider one wall panel, so how it will be bent, how uh, what will be the approximate bending moment for that wall, what will be the approximate shear force, where will we I will get maximum forces, bending moments or shear forces, what will be the bending deflection pattern. So that should be we know. So if you directly go into that software, so it might be difficult if you are beginner. If you are expert, then okay, don't waste your time, directly go into software. But apart from that, there is a one more easily manually method that can be used as a PCA tables. Okay, so I mentioned last time also. So you can see I have opened this PDF PCA table, that is a Portland Cement Association's table, and this is for the rectangular table. So is it visible, this PDF?
Yes, sir.
Okay. Okay, so basically I will share this, or maybe if you have already, it is easily available on Google or somewhere, so you can download the PDF. So a very simple, very beautiful, and very fast tool that can be used for analysis and design of the water tank. Not only water tank, maybe you can consider as a plate also. Like if you want to design a slab, so you can use this plate also based on the support condition. So I will not directly go into this introduction. Maybe you can read when you get time. Definitely you will, I encourage that you will just go through each and each page. But due to the time constraint, I will try to simplify and explain you how to use this directly. Okay, so you can see this, some this index. Okay, so these are the index and there are different load cases are mentioned. So load case like case 1, case 2, case 3, and we have, you can see there are some aspect ratio also. Okay, so if I go to the case 1, so this is the elevation of any wall panel, so any wall panel. So I'm not taking in our example, but this is like a generalized case in which you can see this the elevation of the wall panel. Okay, and what is this mention, this triangular and this so it gives that this wall panel is hinged at bottom and top, and this wall panel is fixed at sides. Okay, clear?
Yes, sir.
Basically this wall panel gives with the support conditions at all its four sides. Okay, and B is the length of the wall panel, A is the height of the wall panel. Okay, you can see the axis also, X, Y, that is almost it's like global axis. Okay, and now this is the loading pattern which is acting on the wall. So what now? So this is the triangular force. Okay, and what is the intensity of the triangular force? That is a Q. Okay, and if I see this table, right side table, what I get from this table, so I am getting the aspect ratio. Okay, aspect ratio means B by A, length divided by height of the wall panel. So I get some ratio, correct? So if the ratio is 4, then where I need to find? So I need to go to the 2-6 page. So likewise, you will get all the aspect ratio from 4 to zero point 0.5. Okay, and respectively you need to go to that page. So if I see case number 2, so what is the difference between case 1 and case 2?
So both side fixed है सर और बॉटम में हिंच और टॉप में सर फ्री.
Correct. So only difference is the support arrangement for this wall panel. So what happened in this case 2? In case 2, two sides are fixed, bottom is hinged, and now you can see this wall, top of the wall is free, as against in case 1, top of the wall is also hinged. Correct?
Yes, sir.
And right side is the same thing, like it will be never change. So you will get B by A. Based on that you can find out your aspect ratio and directly go to the page number. So if I go to the page number 3, case number 3, so now what will be the case? So now this wall panel is fixed everywhere, fixed at side, fixed at the bottom, and top free. So like on the right side same. So if I go to next case, 3 side fixed, top pin, next 5 all 4 side hinge or pin. Case number 6, what is the difference between 5 and 6?
सर 5 में हिंच है और इसमें दो साइड फिक्स है और दो साइड हिंच है सर. 6.
Correct, and one more difference is clearly visible. So what will be that?
Water pressure.
Correct. So up till case number 5, you can see this, the water pressure is at in triangular shape. Okay, so from load case number 6, what happened? We are getting the rectangular, like a uniformly distributed pressure, or maybe you can call it as a UDL. So that is also different from the load case and 5. So now from 6 onwards, what you will find? So everything will be like similar to this UDL. If I go to the load case 6, UDL, load case number 7, UDL, and and here on the wall panel, yes, definitely support arrangement will be get changed. But from 6 to, I guess it's 9 or 10, you can see there are UDL which is acting on wall panel on different type of support arrangement for the wall panel. Okay, got it?
Yes, sir.
Any difficulty till now? Any questions? Why like this or something like that?
Sir, why is support changed?
Support chain, like definitely yes. So how we are doing, like, so wall is fixed at the bottom. Okay, means what you are doing, so you are providing your reinforcement, which is your reinforcement, wall reinforcement needs to be developed into the base slab. So what happen? So moment into wall which will be get transferred to the base slab. Okay, and how it will get transferred to the that reinforcement. Correct. If you don't provide that development length for the wall, so it will not transfer to the base slab. So what will be case that, so it consider as a wall is pinned. So what happen? So because of that, so always I will try to draw something. So this is wall section. This is my base slab. Okay, and these are the my walls. Okay, so if I, because of water pressure, what will be happen? Maximum movement will be at the base. Suppose this wall panel is pin. Uh, right, gets hmm, okay. So this is fixed. This is fixed, and assume you have UDL. Okay, so what will be the bending moment pattern? How you can find out the maximum bending moment? It's very simple. It's a very we have empirical formula. Maximum bending moment, that will be WL square by 12. Okay, so if I try to draw bending moment, then what will happen? Maximum bending moment will be at the support. Correct. So bending moment will be like, diagram will be like this. Oops, not like this. Correct. So this is negative moment, some positive moment. This is negative moment because we have ends. Supports are fixed. Fixed means what we are doing, we are providing this reinforcement of the wall, or maybe you can consider beam, is developing inside the slab. Okay, because of this bar, this moment is get transferred to the slab. Suppose if I'm not developing this, so then what happen? Suppose I'm just is curtailing this, so just only pin. So this case can be considered as a pin, only hook. Then what happen? So that length of the bar is not sufficient to develop this moment to the base slab. So what happen? So this pattern will be changed. You can consider as a pin. this is pin, and you know, for pin connection, bending moment will be 0, correct? So what happens? So bending moment will be 0 at the ends because we have pin connection, because this bar is not capable to transfer the bending moment to the base slab. So what happens? The total amount bending moment will be changed, but same, but the number will be changed. So instead of at the moment, it will be something somewhere maximum at the center, and this will be totally positive moment. Okay. So based on your detailing and based on your assumptions, your location of the bending moment will be changed at different location. So if you assume pin, hinge or pin, so based on that you have to detail when you are going to prepare the structural drawing. So you have to be very, very careful. So if you go initial stage, if you consider hinge, then definitely when you are detailing your bar, so you will not increase this length, or you will not embed, provide the development length to the bar. So in that case you have to just provide hook, so it will be stopped there. If it is fixed moment, fixity, then you have to provide the embedment depth, all development length to the bar. Okay, that's why we have different options. Okay, so what will be the if there is a hinge condition, pin condition, but for water tank mostly we used only fixed condition for three side. Okay, for three side we like wall to wall connection, wall to base slab connection, so that will be 99.99% will be fixed to avoid leakage and those things. Okay.
Okay, sir.
Okay, so maybe now we will start our bending moment calculation, but for that example, maybe we will consider our tank is a cantilever for the maximum worst condition. Okay, we right now we will just ignore that we have a roof slab. Okay, so then what will happen? So our wall will be acting as a cantilever. Okay, so if I will take one panel for this 12 meter, one panel. Okay, so what will be the dimension if I want to see this from this direction? So what will be the dimension for that? So this is the elevation of my wall panel. The length will be 12 meter, correct? And height will be 5 meter. Got it? So that is B, and this is A. So what will be the our aspect ratio? So if now what happened? So this is my wall panel. This is fixed at other wall, fixed at the base slab, and fixed at the other wall. And let's say we don't have roof slab, so this is free. Okay, so now we want to analyze this panel for water pressure, that is for the triangular pressure. Five meter means our water pressure is 50 kilonewton per meter. Okay, we already calculated that for test condition. We consider tank full, so this will be the 50 kilonewton, that is our pressure which is acting on the tank. Till now, okay?
Yes, sir.
Okay, so our first task now that we need to find out the aspect ratio based on this support condition. So I will go directly again to PCA tables. So I don't want to go with this rectangular loading pattern because I am calculating my bending moments for the triangular pressure. So I will directly start with this. So is this our case? Case number 3, 3-side fixed, top is free with triangular pressure, correct?
Yes, sir.
And what will be our aspect ratio? B by A means 12 by 5. What will be that?
2.4.
2.4. So just go through this. So do we have that value? B by A is 2.4. Do we have that value? No.
No,
So
sir.
we
No,
have
sir.
2.5 and 2. So definitely you can interpolate. Otherwise, you can directly assume 2.4 is equal to 2.5 on little bit on higher side. Don't go with the 2 because it's 2.4. Even though it is 2.1, I recommend use 2.5. If you don't want to interpolate, definitely you can interpolate to the up to the exact, but it will be take some time. Okay, that's why I recommend, even though it is 2.1, 2.05, just go with the 2.5. And now we can here. So to for 2.5, we can directly go to the page number 219. Okay. Page number 18,
Yes,
page
sir.
number 19. Is it visible for you? B by A is equal to 2.5. Okay. Is it visible?
Yes, sir.
Okay. So now again see. So from this table, we have different types of coefficients. So how to use? Okay, I will explain you. But how to find out the bending moment? So bending moment we can calculate with the coefficient into Q A square divided by 1000. Okay, this is empirical formula. So now our task will be how to find out the coefficient. Okay, but before that, I want to explain all these different tables. Okay, we have one, two, three tables. So I will explain you one by one. So you can see this. This is the wall or wall elevation. You can see this x-axis, y-axis. Okay, and we have different tables like mx, my, and mxy. So obviously mx means moment along x-axis and moment along y-axis. Hmm. So again, I will go to this. I want to draw something. This is my wall panel. This is X. This is Y. Okay. I don't want to draw this support. Okay. You know, like we have 3-side fix. And suppose this, and obviously this is the front elevation or front view. Okay. And for any wall, we have two types of reinforcement, correct? Vertical and horizontal. Agree? So
Yes, sir.
suppose, so this is my blue color represents, I'm just providing one example. So let's say this blue color represents vertical reinforcement and this purple color maybe represents horizontal reinforcement, irrespective of its spacing, its diameter. Okay. Okay. So our main purpose is to find out the bending moment, to find out the area of steel, and based on that we can find out the reinforcement. So our ultimate aim what is that we have to provide the reinforcement into the wall panel. Okay, that is correct. This is the X, this is the Y. So I am asking you one question. So obviously like PCA tables gives me different tables like MX, MY, bending moment along X axis, bending moment along Y axis. Okay, that is fine, but I want to find out the I want to find out the moment for to provide the reinforcement for the vertical steel. Okay, for vertical steel, for this steel, for vertical steel. So for vertical steel, which moment I need to calculate? Vertical bar. मुझे वर्टिकल रेनफोर्समेंट कैलकुलेट करना है, निकालना है, तो उसके लिए मुझे कौन सी मोमेंट फाइंड आउट करनी पड़ेगी, mx और my?
My.
My. Any other answers?
MX.
Mx. Any more thoughts? Are you agree with my or mx? Okay, so let's see. So we need to find out the vertical reinforcement, correct? This means this moment will be along x direction. Then only we can find out the vertical reinforcement. So your wall is like bend, which is parallel or which is along the x direction. In that case only you can find out the mx. So my answer is not correct. Okay, got it? So if I want to find the vertical moment, vertical reinforcement, I need to find out the moment along x-axis. Okay, because wall will be like bend like this direction, correct? Something like that. I will erase this. And now, if I want to provide the horizontal reinforcement, so it's obviously like my. So when my wall is try to bend along y-axis, correct, like this way. So my horizontal wall reinforcement will be resisting that moment. Okay, correct? Clear? Bending pattern. Wall कैसी bend होगी? Along x, along y. Why we need to choose mx? Why when we need to consider my? It is clear?
Yes, sir.
Okay. And the last one, mxy. So if there is any torsion, twisting, so in that case, maybe you can consider the mxy. So in that case, like this moment is somewhere in between my and mx. So generally for tank, for this kind of rectangular or a triangular pressure, it will not be possible this twisting moment. So maybe we don't need to consider this mxy. Okay, so our main intention or main interest for only these two tables, mx and my. Okay, yes. So now we can see this. There is also one row and one column that mentioned top and bottom and from different heights. Like if I consider both are same, like if you go my or mx, yes, top to bottom 0.9 to 0.1a. Okay, so what is this from top and bottom means I can find out moment x anywhere from top to bottom at any distance. Suppose I want to find out moment at point A. Okay, so if I go to my figure from bottom point A, point 1A means what is the dimension? Our height is 5 meter. Okay, 5 into point A. So 0.5 meter, suppose some out of you, someone's want to find moment at 0.5 meter. that is a point A. So you can just refer this row only. And so this is now only one location. Okay, this is along height. Again, there are another row. You can see at the top of this table, end. Okay, end and 0.5b means end means this end and this end. Okay, and now if you go 0.1b, 0.2b, 0.3b, 0.5b, 4b, 5b, like this, same thing. So maybe if you want to go with 0.1a for height and let's say 0.2b. So like if you plot this, so if you want to calculate bending moment at this particular location, 0.1a and 0.2b, yes, you have the luxury. Just go to this 0.1a and 0.2b minus 33. You will get the coefficient as a minus 33. If someone asks you, no, I want moment at 0.4a and 0.4b. So is it possible to get that? Yes, absolutely possible. Just go 0.4 and 0.4. What will be the coefficient? That is a 3. Okay. So based on that, you can find out the bending moment into the wall panel at any point, at any height, at any length of the wall panel. Same with this also, my. Okay, got it?
Yes,
Understand
sir.
why this top and okay, and why there are some different values like minus to plus? Is there any idea why it's like there? Why all not minus? Why all not positive?
Tension and
Holding
compression, sir.
sagging.
Sagging and holding.
No, it's correct. Sagging and hogging. Yes. And basically what happens? So if I will
Hogging.
draw a, maybe I will draw a line. This is my free body diagram of fixed wall, top free. Obviously we have zero bending moment at top. Okay. For this water pressure, you can try it in your STAAD also, or we have ready-made formulas in your textbook also. So this is triangular pressure for free. So what happens? So bending moment will be like this. This is a positive, this is sagging, and this is a hogging. Okay. That's why for all negative means we are getting the tension or hogging moments, and this will be positive things. That's why we have see the different in a plus to minus. Okay. Got it?
Yes, sir.
Okay. And again, so this is very important in the aspect of this detailing purpose. So again, I will try to draw section of the wall panel. This is the section, cross section. Okay. So this is my inside wall, inside water pressure. So because of this, what happened? I will try to idealize this as a bending moment diagram here. Because of this, what happened? Wall be like bend like this. Okay. This is negative, positive, sorry. Positive, negative, internal. So ideally, this is my inside face. Inside, outside. Okay. So because of wall water pressure, my wall will be bent like this. Okay. Forget about the number bending moment. What is the bending moment? Okay. So general bending moment will be like this. Okay. This is negative. This is positive. Okay. So ideally for this hogging, where you are going to put the reinforcement. So maybe if I draw, I know this is not matching, but assume this height will come somewhere here. Okay. So ideally you have to provide because at this portion your wall is subjected to tension because there is a no compression. Someone told me compression, those things. No, bending moments create only tension. Okay. And that's why we are providing the reinforcement. So for this hogging moment, where we have to provide the reinforcement, on which face? Again, this is my inside and this is outside. Okay. So for this, I want to provide my reinforcement at this face. Okay. For this. And now for this tension, sagging moment, because it bends at this face. So I want to provide the reinforcement at this space. Okay. Got it? Any questions till now? Because this concept is very, very important. This concept is required for your lifetime.
सर एक
Any
और
question?
बताइए दोबारा बताइए सर
I'm not able to hear you properly.
सर एक बार आप बता दीजिए
Okay. So this is the hogging because of this water pressure. What happened? ये wall पे inside पे hogging moment आ रहा है, outside पे top पे somewhere sagging moment आ रहा है. Okay. For hogging moment ये inside की तरफ है. That's why we are providing the reinforcement rebar. बार जो होता है ना, हमने inside में provide किया और ये sagging को take करने के लिए हमने यहाँ पे बार provide किया. Okay. So ideally is this okay? Practically is it possible? हमने बस यहाँ पे बार प्रोवाइड किया. ओके. हमने यहाँ पे बार प्रोवाइड किया. Ideally yes, based on the technicality, yes. So this bar can be, your wall is sufficient to take this hogging moment for here. But हम ये ऐसा नहीं कर सकते ना. यहाँ पे हम कैसे रखेंगे कैसे यहाँ पे ये बार. Okay. So this is the only half part. Okay. Now I am just trying to draw different things. So this is, now we are talking about the only inside internal water pressure. Suppose what happened, so if it is the water pressure is from outside, soil pressure है. तो मैं इसको थोड़ा डिलीट करता हूँ. I don't have space. This is now outside face. ये मेरी wall है. So now what happened? So this wall or the bending moment will be now like somewhere like this. This is negative. This is positive. Okay. Or maybe I will. So now for this also you need to provide the reinforcement. So now you are just taking care for the internal load pressure. You have not considered anything about the external load pressure. So now what happened? So to take care of this, so you have to provide reinforcement. I'm just trying to use a black color at this location. So this bar is going to take care for your this hogging pressure, hogging bending moment, and this positive bending moment, you need to provide the bar somewhere here. Okay, this is about just for the vertical reinforcement. So in practical हम ऐसा नहीं कर सकते ना कि ऊपर का टुकड़ा अलग, नीचे का टुकड़ा अलग, हमने यहाँ पे ब्रेक करके डाला. So that's why practically what we do, so we will just provide one bar throughout, or maybe we can provide some lap also if the height is more. Correct?
Yes,
So
sir.
in that case, what we need to be ensure that yes, so this bar is sufficient to take care of this hogging moment. Sorry, water moment. This bar is sufficient to take care of this moment, and at the same time, this moment also. Correct? Alternate. Understand?
Yes, sir.
Okay. Any other questions? All good? Venugopal, Bhakti, Avinash, Samir.
Yes, sir.
Okay.
Sir.
So this is about the providing reinforcement based on the bending moment. So we should know why we are putting, where we are putting, and what is the logic behind this. Okay. Yes, someone want to say something. Okay. So I assume, yes, all good. So now we know where to provide reinforcement, why, how, where. Okay. And same thing like if I go to the horizontal reinforcement, so for that, what I will do. So let's assume this is a plan. This is a wall plan. This is not elevation or not section. Maybe our length of the wall is, I will try to give the dimension here, 12 meter. Our wall panel is fixed. Correct? So suppose this is the inside face. This is outside. Because of the wall pressure, what happened? Because of the fixity, what happened? There will be positive bending moment. At this ends, this is negative, negative, this is positive. So ideally, same thing. You have to provide the bending moment for negative, like this is the hogging, no? So you have to provide bending moment somewhere here, here, and this is a positive means for here. Same thing happened, reversal of the loading because of the soil pressure. What happened? So for that, you are providing reinforcement here, here, and here. Okay. So this is about the horizontal reinforcement. So I can show the vertical reinforcement like this. Don't worry about the diameter, spacing, but just I'm trying to explain you the conceptual level. Is it helpful? No? Okay. No reply. Okay. So now again, we are coming back to this, how to find out the bending moment mx and my. So generally what happen? Again, I will try to erase everything. So suppose this is my wall panel. So when you go and design any wall or any structure, you don't need to find out everywhere, correct? So most of the time, what you have to do, you have to design or you have to find out the worst bending moment. Okay, worst case. This is the maximum. Okay, above that there will not be anything. Correct. So what we need to do? So we need to find out the maximum bending moment. Correct. So for mx and my. So how we can calculate that? So just go in this table mx. So I want to find out the mx, that is for the calculation of the vertical reinforcement. So where is the maximum coefficient? So maximum coefficient is minus 109.
सर
Okay, at the hmm,
सर ये जो हम लोग टॉप और बॉटम में हाइट दिए 0.1 A1, ये हम लोग खुद से दिए ना?
hmm,
0.1 A 0.2 A ये हम लोग जो दिए डिजिट, तो हम लोग
hmm,
खुद ही दिए ना इसको सर?
हाँ खुद ही दिए.
फिर उसके बाद ये हम लोग जैसे हमको यहाँ निकालना है मोमेंट, तो कॉन्फेंसेट निकालने के लिए यहाँ पर इंटरपोलेशन करेंगे.
करेक्ट है.
ठीक है, तो ये हमारा जो 33 आया आप उस समय लिए थे, ये किस तरह आएगा इंटरपोलेशन करने पर?
नहीं ये अगर मुझे 0.1 A, ओके 0.1 A मतलब कितना? 0.1 A मतलब कितना हो गया हमारा? A कितना है? 5 मीटर है, तो कितना हो गया? 5 इंटू A 0.1 कितना हो गया?
5 इंटू ए सर
0.5.
0.5 हो जाएगा.
हाँ 0.5 हाइट पे और एट द 0.2B. ओके,
यस सर.
तो वो उस लोकेशन पे सपोज 0.5 यहाँ पे आ रहा है, 0.2B मेरा यहाँ पे आ रहा है. अगर मुझको यहाँ इस पॉइंट की मोमेंट निकालनी है तो मैंने आपको एग्जांपल बताया, दिस इज नॉट रिक्वायर्ड. if I want to design this entire wall panel, what I will do, I will just go and find out the maximum, that is minus 109, sorry. Okay, which
Yes,
where
sir.
it is comes at the bottom. Okay, obviously maximum bending moment for the fixity at the base, and where it is somewhere at the mid span. Okay, that is 109.
Yes sir.
Okay, so now what will be my bending moment? So you have to this like coefficient into q. What is the value of q? Suppose I am calculating for the water pressure. So what is the q? That is a 50. What is
50.
a? What is a?
area.
5 meters.
Area.
नो सर, वो डायमेंशन ये दिया हुआ है वहाँ पर जो आप
height of
वो
wall.
क्या है? डायमेंशन. हाँ, height of the
हाइट
wall divide by 1000. So please calculate what will be the maximum bending moment for our internal water pressure. You got the answer?
136.25.
Okay, correct. 136.25, and that is the without factored. Okay, if you want to find this factored, so based on your load combination, maybe you need to add the factor also, like 1.2 or 1.4. But understand how to calculate bending moment mx.
यस सर.
Okay, so now please calculate the bending moment my, maximum bending moment my for water pressure.
इसके बॉटम में लेंगे -22 कोफिशिएंट.
No, I told you like consider maximum. -22 का डिजाइन किया तो वॉल फेल हो जाएगी ना अपनी।
हाँ ये मैक्सिमम सर -27 टॉप पर है। नहीं सर सॉरी 0.9 ए पास -82।
हाँ तो कैलकुलेट कीजिए कितना आ रही है बेंडिंग मोमेंट MY के लिए, हॉरिजॉन्टल रेनफोर्समेंट के लिए। Got the answer?
102.5.
Correct. Correct. Yes. So you consider maximum coefficient as a 82, correct? And you have calculated MX and MY. Sorry, for MY. So this way you will directly get the bending moment for internal water pressure. Okay. Now we have the if I go to this wall soil load calculation, where is that? Okay, soil pressure is a 55. So please let me know what is the maximum bending moment MX for soil pressure. That is a 55.
$150.42.
Almost close, but not correct. Can you please check again?
149.87.
Correct, 149.87. Yes. So you can take it as a round of like 150 or 155. That's fine. So this is not like a 2 plus 2 is equal to 4. So yes, we have to just take care that it should not go less than 149 point something. Okay, so just calculate the MY also similarly for 55.
$112.75.
Correct, 112.75. So this way what we get all the bending moments and shear force. If I go, I hope you have written down all these values. If not, that's fine also. Or maybe I will go, I think I have somewhere. Yes, this is somewhere, but that's fine. I just write it answers here. Okay. So now we have calculated the bending moment. So now what about shear force? Okay. So there is one another parameter, that is the shear force, that we need to check. Correct. Up till now it is clear how to calculate the bending moment. If I go like this, PCA table is very beautiful, quick tool for like submission of tender purpose. So just only within 2 to 5 steps you can design the water tank. Correct, because now I am explaining you, that's why we are taking much time. But if I know this, how can I solve it? So I will just, what am I about step? B by A. I will fix the B by A. Correct, blah blah blah. Based on that I will go to directly that page. I will calculate MX, MY. for both water and soil. Just only one formula. Just only one formula. You will get answer. You will get values. You will get values. Correct? You can see just only 1, 2, 3, 4, 5 steps. Just with these 4 to 5 steps, you are getting bending moments. Okay. Now we are missing one thing. What is that missing thing for the soil pressure? We just calculate bending moment for triangular pressure. We haven't considered surcharge, that is a UDL. Okay. So what is the I think 149 something like that, correct? 150. Am I correct? MX.
MX M112.75.
No, so for soil, for MX, I think 109 into 55 into 25 divided by 1000, 149. So let's say 150. That is due to the soil pressure. So I will try to write down somewhere here, or maybe I can add one more page here. New slide. That's fine. MX for soil for angular pressure, correct? Or maybe for soil only. What is that? 150 kilonewton meter. Okay. My for soil. That is 112 something. Value is not important. The concept is important. Okay. So now we have just covered only triangular portion. So what about surcharge? Correct. We have surcharge also 10 kilonewton per meter. Correct. So we have to consider this additional pressure. How to consider that? Again, go back to the PCA table. Go to your index where all the load cases are given. Now, instead of triangular, we have to consider this rectangular loading pattern. So just check for our load case. This is not, yes. So our case is case number 8 because we have 3 side fixed top free, assuming cantilever, no roof on the slab. Okay. So now what is our aspect ratio? Aspect ratio will be same. There is no change. So aspect ratio is 2.5. So I will directly go to the page number 49, 2-49. It is still 19. $49. Okay. What is our aspect ratio? 39 or 49? Okay. I'm here. Yes. So this is our case. Triangular pressure, rectangular pressure, 3 side fixed top free. So same way, please calculate the maximum bending moment for vertical MX. I will tell you your answer. Once you are done, tell me your answers.
$71.5.
Correct. So let's assume 72. So what I need to do, I will go back to my that calculations. I need to add plus this 72. So what is the final moment? 150 plus 72. Got it? Now calculate for my also.
$83.5.
Correct. So now we have to add this 84. Round make. I did just round off. 84 plus 112. So 193 kilonewton meter. Understand why I added this 72 and 84? Because for external side, wall is subjected to triangular pressure plus surcharge. That's why what we did, so we added this bottom values: maximum bending moment due to the triangular pressure plus maximum bending moment due to the surcharge that we have added for both, that is mx and my. So this is the additional bending moment which is generated due to the surcharge. Okay, understand?
Yes, sir.
Okay, so this way we have completed the bending moment. Now shear force. How to calculate the shear force? For that, again, I will go back at the top of this our what we call index or the load cases for triangular. So we have load case number 3, 3-side fixed, top free. We have this 2.5, that is a page 219. Okay, or maybe we will just go to the page number 218, the first page. Why? I will tell you. 218. Okay, the load case number 3. Can you see this? The same load case. And at top of this, we have just, we can see this, how to calculate the shear force. Now, they have given shear force is equal to CS into Q into A. Okay. And we are getting the location also. And these are the aspect ratio, B by A. Okay. So now what is our aspect ratio? That is 2.5. So we are more interested for these three values. Can you follow my cursor?
Yes, sir.
Okay. So to calculate shear force, our aspect ratio is 2.5. Okay. Now there are three values. So where we need to consider. So this table gives, like similar to the bending moment, we are getting many locations from point 1A to point 9A, and from left to right, like point 1B to point 5B. So in the same way, this tables gives bending moment at three different locations, where bottom edge midpoint means this is the my bottom edge midpoint. Okay, I can calculate the shear force at this location: bottom edge midpoint, side edge maximum. For this all two sides, I'm getting anywhere, but that is maximum. Okay, and side edge midpoint, someone asked me calculate the shear force at the midpoint for the sides. Okay, so I can give that value also. So I can find out any maximum value for the side, any maximum value at the midpoint, and at the base, so I can find out the mid. But again, I'm more interested to find out the worst case. So irrespective of location, technically you should know where we where you are getting the maximum shear force. Okay, if someone asks you where you will get the maximum shear force in wall panel, so based on this coefficient, you can say always maximum shear force will be at the bottom somewhere around the midpoint. Okay, and if you are talking about the side, yes, I need to just check side maximum. Yes, so I can find out at mid and also side also. Correct. So now just calculate shear force for wall 2.5 aspect ratio with water pressure. So this formula is there, and let me know your answers. Shear force. What is the value of shear force? Just go with the maximum.
One 20.
Correct. 120 shear force due to water. What is the unit?
Newton or kilonewton.
Kilonewton. And what is due to soil?
132.
Let me check. 132. Is it only 132?
Sir, I have fixed my calculator, so it is 132.
No, no. But again,
Kilonewton.
we need to add shear
Okay.
force
Sir,
due to the surcharge.
surcharge.
Okay, for water is fine. So there is no surcharge. So we are done with the water. But when it comes to the soil, we have to consider surcharge. Not only we don't need to just stop here. We need to consider surcharge. Again, how to calculate surcharge? Is it okay to use this formula? Use this coefficient to find out surcharge?
No,
No.
rectangular.
Yes. So again, go back to your load case diagram. I think load case 8. Yes, load case number 8, page 248. This one. So now calculate what is the maximum shear force due to the surcharge. Maybe I think I request Bhakti, you don't tell now. You can give some chance to other guys. But on the background, yes, you definitely can calculate. So I will ask Venugopal or Shahaji, Hema.
47.5.
Okay, let me check. 0.95 into 55 to 5. Is it correct? What is the value search shear force?
Kilonewton.
No. What is the value? I don't remember. 5. Okay. What is
It
the
is
maximum?
10.
Huh?
Q is equal to 10. No?
Q is equal to 10. Correct. Q is equal to 10. What is the maximum shear force? 74.
Yes, sir.
Okay. I think at first instant I consider 55. So 74. Okay, that is also kilonewton. So what is the total shear force? 74 plus 132, 206. So whenever you calculate your wall to check the shear force, you need to consider this. It's absolutely fine if you don't consider this, because shear force is always governing, which is maximum. But only one thing here, whenever you go for design, you these all these are the service level. We haven't considered any factor. Okay, so like if you have a load combination 1.4 dead plus 1.4 soil or 1.4, so you have to, if your load factor is 1.4, then you need to multiply this value 206 into 1.4. So your shear force ah, design shear force is equal to 206 into 1.4, that is somewhere 289 kilonewton. Okay, and same way you need to multiply these moments by 1.4 if you have factor 1.4. Got it? You need to multiply this 1.4. I will not directly calculate the answer, but don't forget to multiply this. Let's say calculate. Why to wait? 222 into 1.4, that is 311. And what is the my? Can you please help me to calculate this? Correct?
So 270, sir.
270. Okay, oh sorry. 271. Okay. Okay, so whenever you design, so you have to consider this highlighted one. Okay. Never consider the service level. Till now, all good?
Sir, we calculated due to soil shear force.
Hmm.
In that 132 we got at the bottom edge, right? And 74 we got at the side edge. So we always need to consider the maximum of three values, regardless of where the edge is.
Yes, like if I go back to this, so side maximum. Okay.
Yes.
So regardless, yes, I recommend yes, because you will not never know. And is it fine? Like for you will reduce that wall thickness somewhere at the side is like different to the at the bottom.
Okay. No.
You will provide uniform wall thickness, correct?
Yes, sir.
So for if you calculate the 1.47, that is somewhere side maximum. So same thickness that you need to provide everywhere, correct?
Okay.
So
But we
that's why.
had to consider maximum.
Yes, we have to consider maximum.
Okay, sir.
And if I go, like again, if this is my wall, so this is my left side is outer face, in right side is the inner face. So shear force from outer side, that is 289, correct? 289. And shear force from inside. Oh, where is it? Okay. So that is obviously less than something, some less than the soil pressure. Okay. So this is acting at somewhere. So what is the governing? So obviously my this value is more. So I don't need to consider this one, shear force. So shear force is always considered maximum. But for reinforcement, yes, even though you have maximum for soil or you have some less than for water sometime, but you have to consider both bending moment, because you can little bit optimize inside and outside rebars, correct? Based on that you can provide. Got it my point?
Yes, sir.
So this way what we did, so currently we have done analysis of only one wall panel. Okay, so this is my plan. So we have just done for one long panel where we have this inside length of the 12 meter. So what about three wall panels? Can you tell me? We just find out the bending moment for this. We find out the shear force for this. What about the three wall panels?
Into 3, sir.
Is it correct? Logical? The first thing. So we don't need to calculate again for this because this 12 meter same. Correct? So once you are done with this wall, automatically you are done with this, because for this aspect ratio also same. Now, this is our 8 meter wall. This is also 8 meter wall. So now what will be the only change? So B by A. Sorry. What is that aspect ratio now? That is 2. Correct? Understand what I'm saying? Are you with me or not?
Yes, sir.
So only change. So for this wall panel, you have to change only this aspect ratio. Correct? So you have already calculated this. So every wall reinforcement for this wall and this wall will be same. So these are done. So now only pending things are this short wall. Okay. So now for short wall, what happen? Only your aspect ratio will be get changed. Instead of 2.5, now you need to consider 2. Okay. So you can calculate the same thing like for 2, shear force 2. Everything will be same. Just your location will be changed. For every previously you calculated everything for 2.5. Now you have to follow the same thing. Each step will be same, but only change is that the aspect ratio 2. Correct? If I go to the bending moment, 219, I guess. This is 1. This is 7.5. 2, 2, 2. It is 2. So instead of 2.5 that we have previously calculated 109, 82. So instead of that, you have to just choose this table and calculate the same thing. Nothing is different than the previous thing. Okay. Got it? Is it? Can you find it at your own for the short wall? This one, this one.
Yes, sir.
Very easy. Suppose again, I will little bit try to complex. So this is my water tank plan view. I will add some more walls into this. Now, how you calculate this? So in that case, what you need to do? So you can just identify wall number. So let this is W1. So obviously this is also W1, correct? Am I correct? Okay, this
Yes.
is W2. This is W2. Why W2? Because this internal wall is not subjected to the soil load. That's why I mention as a W2. Okay. Now I can use this is as a W3. This is same W3. This will be W4. This will be again same W4, W5, W5. Now is it simple and same that I have considered earlier one? Same thing. So you have to just find out the lengths. Height will be same for entire wall, all walls, correct? Is it clear? So based on this, can you find out all the bending moments and shear force all from W1 to W5? Is it possible?
Yes, sir.
Very easy, because all the loadings, those are common for all walls. Okay, except this, because this is also only same thing. We don't need to consider only soil load, correct? Because these are the internal walls. Apart from that, yes, everything will be same. So what happen? So maybe the geometry will be changed. Instead of this, maybe there one example that maybe you have like this one partition. No problem. So this will be the same thing. Okay. So it's up to you how to simplify different wall panels.
For W2, there will be triangular load outside, no?
Triangular load outside, both side also. Correct.
But we have
What?
to consider that
At
triangular
only
case,
once.
right?
Correct. Only
Okay.
once. Either this one or either this one. What happen if both tanks are filled? What happen? All this pressure will be get cancelled because of both pressure
Okay.
are acting against. So
Hmm.
is there also possibility this is empty or this is filled? That maybe this wall will try to bend like this. Okay, or maybe this is empty. There is water. So as I mentioned, we have to consider always worst case. So if you consider my tank is always filled from both sides, so I don't need to consider, I don't need to design this wall. No, there may be some instances that this wall may be subjected to water pressure from only one side. And yes, whenever water is there, yes, it's always a triangular pressure.
Got it, sir.
Yeah. So now I am asking one question. So if I give one example of tank with some dimension, are you comfortable to analyze? Because we have just analyzed, we have not designed. What is the difference between the analysis and design? Analysis means we have calculated everything in terms of the because of the loading. Okay, we calculate the bending moment, we calculate the shear force. Now what is the design? Based on that input, like the bending moment, shear force, we have to find out the reinforcement. So that is our ultimate aim, to provide the reinforcement and to create a structural drawings. So based on that, construction can be performed. Okay. So now if I ask you, are you able to analyze any tank with using the PCA table, by using PCA
Yes,
table? Very
yes,
simple.
sir.
It's a very simple, just step by step method. You just go and complete it. Okay. I am intentionally not covering any design at the moment, because design part is every similar for everything, whether it is for the FEM or software things or PCA table. So I will club everything together and explain you. That's why I'm not considering that design moment at the today. Definitely I will cover, but not today.
Sir, if you learn this, the stat is not required, no, sir, for this design.
What can you please repeat?
Sir, if we learn this method, the STAAD Pro is not required now, sir, design.
It's up to you. Suppose if you have some complex geometry, then definitely you need to use the STAAD. Some different types of loading. So yes, that you need to consider. But this is the very best method, quick method. Maximum in 1 hour you can design. You don't need to open your any software, go that and model, apply the loads, extract the results. So just within one page, single one page, you can complete your analysis and design. Okay, so maybe we will stop here. In next session, we will use PCA table for circular tank. Okay, till now we have done with the only circular rectangular tank. Rectangular, maybe you can consider as a square, so it's different, not because it's just based on the length and height, whether it is a rectangular or a square. So that's fine. But in next session we will start working on analysis of circular tank by using PCA tables. Okay.
सर
Hmm?
आपण 3370 पण आहे तो म्हणजे वॉटर टँक साठी डिझाईन साठी यूज करतो ना.
बरोबर. हो.
मग हे म्हटले कुठले टेबल आपण 337 मधले म्हणजे टेबल यूज करू शकतो का डिझाईन अनालिसिस साठी?
नक्कीच करू शकतो. नक्कीच करू शकतो. पण maybe you can do exercise. So maybe you can take one example. Maybe you can take this also, 12 meter by 8 meter, and try to check by using which code? I don't exactly.
3370.
Ha. तर ते पण घ्या. Maybe you can use that and just compare with the PC tables also.
Okay.
Because the beauty of PC table is this can be used for universal code. So you can use it for the BS code, you can use it for the American code, you can use for IS code, because this is not any specific with the associated with the any code. Okay, suppose you want to do tank analysis for based on the US code, so you cannot use that IS code tables, correct? But definitely you can use this one, because these tables are irrespective of design codes, and like these are the only coefficients without any unit. Maybe you can use for that feet inch method, you can use for meter also, correct?
So can this method use for some RCC buildings?
RCC building, yes, up to some extent. Like if you want to design slab, any slab, okay. So PC tables not mention that this is only for water tank. So it is the wall panel. Maybe this is slab also. So you can use this to consider this is a slab fixed at 3 side, and maybe you can apply. Maybe it is subjected to the live load 5 meter per 5 square meter, or maybe 3 live load. Okay. So what will be that? It's like a UDL. So you don't need to consider this triangular. Just go for that rectangular pressure. You can find the bending moment.
Okay,
Got it?
yes.
But for wall panels, like only the concrete walls, you cannot apply this for that brick panel. Okay. So if it is on shear walls, yes, then you can design it.
Okay, sir. Thank you.
So it's to you how you can apply this. You can consider wall, you can consider slab. It's up to you. Okay. So I think all good. No questions. Maybe we can conclude our today's session, and we will meet again by Monday.
Okay, thank you, sir.
Okay. And in between, if you have anything questions, okay, maybe we can discuss it by Monday also. No problem.
So इसका base slab design नहीं है?
We will consider that base lab. I will
Okay.
explain you in the next session.
ठीक, okay.
Yes. Yes. Okay. Thank you then.
Thank you, sir.
Yes. Bye. Bye.
Good night, sir.
खराब हो गया